Welcome back. In this section, we will use a relay ladder logic diagram to explain how, for example, input, logic, and output devices are arranged to control the runtime of an electric motor. Here is the ladder diagram showing all the input, logic, and output devices. Notice that we have two input devices, namely a start switch and a stop switch. The logic devices are the motor control relay and a timer unit. The output device is the motor. The ladder diagram has 3 rungs which are numbered outside the left-hand rail for easy reference. Outside the right-hand rail, notice that certain information is provided. Firstly, each coil is identified by its function. Coil 1CR is the motor control coil being used to switch power to the motor. And coil 1TMR is the timer or delay-on relay controlling the runtime of the motor. Secondly, there are numbers below the coil descriptions, and these numbers refer to the rungs on the diagram, which contain any contacts controlled by that coil. If the number is underlined, it means that the contact is normally closed. The number tells us that the timer's contacts are part of a circuit on rung 2 of the diagram. The underlining tells us that in their normal or inactive state, they are closed. These references are invaluable when dealing with complex circuits, especially during troubleshooting operations. Now let's analyze the power flow step by step, or in this case, rung by rung. The first rung on the ladder contains the operator's start and stop switch, wired in series with the motor's control relay. This circuit is usually described as a series, or an AND circuit, since both the start switch and the stop switch must be closed for power to flow across the rung and energize the control relay coil. If either one of these switches is open, power flow to the coil will be interrupted and the motor will not run. Rung 2 contains the retain circuit for the motor control relay and consists of contact CR1/1 wired in series with the switching contacts 1TMR of the timer relay. Now both these contacts on rung 2 are connected in parallel with the start switch on rung 1, so that the motor control relay coil will be energized by either the start switch 1PB or by way of the retain circuit on rung 2. This configuration of switching contacts is termed a parallel circuit, or an OR circuit, since the output is true when the contacts on rung 1, or the contacts on rung 2, are closed, allowing power to flow across the rung. Now that we know the meaning of a series and parallel circuit, we can see that the first 2 rungs of our diagram represent a combined AND OR circuit. When describing the power flow in a ladder logic diagram, it helps to remember the following 2 important points. Firstly, contacts are always shown in their normal or inactive state, and unless something is done to activate them, they will remain in that position. And secondly, whenever a switch is activated or a relay coil energized, the contacts controlled by that switch or relay will change state. Now let's examine the operation of the first 2 rungs using this simple model to simulate the control circuit. The cycle begins when the operator presses the start switch. The switch contacts immediately change from their inactive state to their active state, and since they are normally open contacts, they will close and pass power. The stop switch is inactive, so its contacts remain in their inactive or normally closed position. The circuit is complete and power flows through these contacts across the rung to the motor control relay, energizing the coil. Both sets of control relay contacts CR1/1 and CR1/2 change state from their inactive to their active state, thus passing power to other devices. The retain circuit is now closed, and the motor runs even after the operator has released the start switch. Power also flows along rung 3 to the timer, and the timer begins its count. Since the timer relay contacts remain in their inactive or closed state until the timer has timed out, the retain circuit remains closed. After the preset delay time expires, the timer times out, and the coil in the timer energizes. The normally closed timer contacts on rung 2 change to their active state, opening the retain circuit. Now the control relay coil is de-energized, interrupting the power flow to the motor, and the motor stops. The control relay contacts on rungs 2 and 3 return to their inactive or normally open position, opening the retain circuit and de-energizing the timer relay, and the timer is reset, ready for the next cycle. We are now in our learning process, fast approaching the time where we shall be leaving behind the old technology that uses relays for the logic and move into the new technology where the PLC controller has taken over the role in a revolutionary way, thanks to electronics and the evolution of microchip technology. In the programs that follow, you will be learning from your understanding of relay logics, how PLC programs operate, and how we can manipulate them using logic diagrams and terminology with which you are by now familiar. Complete the exercise in your workbook before you join us again in program number 3.